Hello everyone, Professor Adjovan here. In this video I want to talk about vertical motion models. So we're going to use this quadratic model to identify the height or the amount of time that it takes something to fall or something that is being thrown up in the air. We can model it with this quadratic equation. So we're going to be doing word problems in this video. So these are the two word problems that we're going to do. Okay, basically we can have a situation where there's like a diver that's jumping up off of the platform and they're diving into the water. How high up are they going to get? At what time are they going to reach the peak of their dive? We can have something like a rock is being dropped into the well, and we listen and we hear a splash of water, and we can use that to identify the height of the water. Both of these situations will be using the vertical motion model. So if your questions that you're currently working on look like this, then this is the correct video for you. So let's go ahead and jump into it. First of all, what is the vertical motion model? So the vertical motion model is this h of t, which means the height is the output and the input is going to be time. Okay, this is equal to negative 16t squared, and this negative 16 comes from essentially gravity, plus v naught, right? V naught is how you would pronounce that. And this is just the initial velocity. And that's something that'll be given to you in the problem, right? And then we also have plus h naught, and this is the initial height of whatever object is being thrown or dropped. Okay, so let's take this, now that we've identified the two pieces of this vertical motion model that might change, let's take it, let's look at an example, and then come up with an actual model to model a specific situation. So in this first question, we have that a diver is jumping off of a 30-foot high platform, and they're doing so at this initial velocity of 16 feet per second. So we want to come up with a quadratic function that represents the height of the diver after some number of seconds. After we come up with that model, we can answer this question: how many feet above the water will the diver be at the highest point in their dive? Okay, so I think it's beneficial to underline key features of the problem, right? Annotate the question so that we can pull that relevant information out when we go to make the vertical motion model. So our vertical motion model, negative 16t squared plus some initial velocity times t plus some initial height. The initial velocity in this question is 16 feet per second, right? The diver is jumping up, which is why this is a positive 16. If they were jumping downwards, which wouldn't really make sense for a diver, but let's pretend that an object is being thrown down, it would be a negative initial velocity, right? Direction is important. They are jumping off of their platform that is 30 feet high, so that is the initial height. Okay, so we have this vertical motion model, and we want to determine how far above the water they're going to be at the highest point in their dive. And we can take what we know about quadratics and identify a key characteristic, right? This is a negative 16 in front of the t squared. It's a negative a in front of the t squared, meaning our parabola is going to be opening down, which means that the vertex of this parabola is a maximum. So if I can identify the vertex, we can identify the maximum height. So the vertex of a quadratic that is in standard form is negative b over 2a. Right, this will give us the x value or the t value in this situation of the vertex. So if we take negative b over 2a, we have negative 16 over 2 times negative 16, which would give us negative 16 over negative 32, which simplifies into 1/2. Okay, so this is 1/2 second is how long it's going to take the diver to reach their maximum height. We can take that 1/2 second and plug it into the equation for t. So we have h of 1/2 is equal to -16 times 1/2 squared plus 16 times 1/2 plus 30. And if we simplify this down, we will find what their maximum height is at this 1/2 second. So 1/2 squared is going to be 1/4. 16, or -16, excuse me, -16 times 1/4 is -4. 16 times 1/2 is +8 and plus 30. And if we do -4 plus 8, we get +4. And then 4 plus 30 is going to be 34 feet. So the diver reaches their maximum height at 1/2 second into their dive, and their maximum height is 34 feet. Okay, let's look at the second example that we have. So in this situation, we have that an individual drops a rock over the edge of a 200-foot well, and we hear it splash into the water in the well after 3 seconds. So we want to come up with a vertical motion model to model this situation so that we can determine what the distance from the surface of the water is to the bottom of the well, meaning how high is the water in the well. So it may be beneficial in some of these problems to draw a picture to get a better idea of what's going on. Right, so we have this well, it's at ground level, and the well is 200 feet deep, that's given to us in the problem, and the rock is being dropped from the top, and after 3 seconds we hear a splash. Right, so there is a rock up here, it gets dropped down, it splashes, and that takes 3 seconds to happen. Okay, so let's come up with our vertical motion model. We have h of t is equal to -16 t squared plus some initial velocity times t plus our initial height. So our initial height is this 200 feet that the well is. The well is 200 feet high. That's how high up the rock is when it gets dropped. That is our initial height. The initial velocity is interesting because we're just dropping a rock. We're not throwing it down. We're not throwing it up. The initial velocity is 0. So if we simplify this equation down before we do anything else with it, we have this vertical motion model of -16 t squared plus 200. So to find this height of the water, we want to look at, well, what's the height of the rock when it actually splashes the water at 3 seconds? Right, so if we do h of 3, -16 times 3 squared plus 200, well, 3 squared is 9, so we have -16 times 9 plus 200. -16 times 9 is going to be -144 plus 200, and combining -144 and positive 200 gives us 56 feet. So the height of this water is 56 feet because that is the height of the rock when we hear the splash. We know that it's 200, the well is 200 feet deep, but we hear the splash of the water after 3 seconds, and using the vertical motion model, we know that that rock is 56 feet off of the 200 feet distance that we have for the well. All right, so this 56 feet is our final answer. If you found this video helpful, consider giving it a like and consider subscribing to the channel. Thanks for watching, good luck with everything, and we'll see you in the next one.